So I start a point, and I really want you to be careful. There is one main thing to be careful with. That is, x is the sine and y is the cosine of x if you're dealing with a unit circle. Notice on this problem it says a point on the terminal side of the angle theta in standard position. X is 5. Assume you moved 5 units to the right and 12 units down. Isn't that the point 5, negative 12? If I run a line from the origin to that angle and always to the x-axis, there's the angle theta. Well, if this is 5, this is 12, wouldn't you say the hypotenuse squared, because that's a right triangle, is 5 squared plus 12 squared? Wouldn't you say the hypotenuse is 13? And it should be plus or minus, but it's positive, right? Why is that? Because length cannot be negative. Well, this is length and it's negative. The hypotenuse can never be negative. Why is that? Because the hypotenuse resembles the radius of the circle, and the radius of the circle is always positive. Otherwise, it would have been negative. Once I create the triangle, they want me to find the 6 trigonometric functions. What's the sine of theta, cosine of theta, tan of theta, assuming you could find the other 3. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And how come we didn't just say this is a cosine and this is a sine? They didn't say it's a unit circle, unlike these problems. How about 84? Well, 0.3 in the x, so if I go 0.3, 0.4, let's say this is 0.3 and this is 0.4. So this is 3 over 10 and this is 4 over 10 because we don't like fractions. There it is. Well, if I draw a line from the origin to that point directly, and to create the triangle, you will always run down to the x-axis, never the y. There's the angle. Well, isn't the hypotenuse squared 3 over 10 squared plus 4 over 10 squared? Isn't the hypotenuse squared 9 over 100 plus 16 over 100, which is 25 over 100? And if I square with both sides, the hypotenuse would be 5 over 10. And the sine of theta is the opposite over the hypotenuse. 4 over 10 divided by 5 over 10 is 4/5. The cosine of theta is the adjacent over the hypotenuse. 3 over 10 divided by 5 over 10 is actually 3/5. And tan of theta is the opposite over the adjacent. That turns out to be 4/3. So if it's not a unit circle, that's how you do it. You could do that even if it is a unit circle. The next 3 problems, they're saying, well, let's see. I have 2 options of doing this, and I'm going to show you both. One option not recommended. The triangle is very useful and easy to use. So one way of me doing this, it says this point is on the unit circle, which tells me the cosine of theta is negative 1/5. And the sine of theta is automatically 2 radical 6 over 5. Because they told me it's a unit circle. That's the cosine, that's the sine. Corresponding to the number t, find the exact value of the 6 trigonometric functions. Well, I could find those 2. Wouldn't you say cosecant of theta is negative 5? And secant of theta is 5 over 2 radical 6. You could rationalize. How do you find tangent? Wouldn't you say tangent of theta is the sine of theta over cosine of theta? Wouldn't that be the sine, which is the y, over the x? Wouldn't that be negative 2 radical 6? And of course you could find the cotangent by taking the reciprocal. Now there is another way of doing this. You could create the triangle. You could say the point, this is negative, so go negative 1/5 and go up 2 radical 6 over 5. If you draw a line from the x-axis, from the origin running to that angle, and always down to the x-axis to create the triangle, this side right here, this length, is actually negative 1/5, and this is 2 radical 6 over 5. If this is a unit circle, isn't that a 1? Because that represents the radius of the circle. Well, there's cosine of theta. It's 1/5 negative. There's sine of theta. It's 2 radical 6 over 5. And tan of theta, I could say there's theta is the opposite over the adjacent. Again, it's really the same thing. The triangle is more efficient unless I'm given sine and cosine, which most of the case I'm not given. I have to find one in terms of the other. Alright, and number 20 again, I could say this is a unit circle. The cosine of theta is negative radical 5 over 3. The sine of theta is the y, negative 2/3. And tan of theta is the y over the x. And that is 2 over radical 5. And if you rationalize, that's radical 5 over 2. That's 2 radical 5 over 5. I'm sorry. If you rationalize. And there it is. Now we get to the actual use of those coterminal angles. Observe how this works. I'd like to know what is the cosine of 7 pi. 7 pi. Isn't this 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi? Doesn't that all indicate that 7 pi, remember, all of these are unit circles, all of them. Doesn't that indicate that 7 pi is right here? And isn't this point negative 1, 0? What's the cosine? What's the x-axis associated with that point? Isn't that a negative 1? Another way of doing this is for you to say, you know what? This is too big. I could add or subtract 2 pi to it. That's 5 pi. That's still too big. Take another 2 pi. That's 3 pi. That's still too big. Another 2 pi, that's pi. So, I can take any angle and fit it into one of these. Pi is right there. Cosine is negative 1. Sine is 0. And tangent is the sine over cosine. And that's how I'm going to do all of those. How about 7 pi over 12? What do you think 7 pi over 12 is? Well, let's see. If I actually run this and say that is 1 pi over 12, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5, 6, 7 pi over 2 is right there. Isn't that point 0, negative 1? I want the cotangent. Isn't cotangent the cosine of 7 pi over 2 over the sine? Cosine is 0. Sine is negative 1. That will be a 0. How about 8 pi? Well, let's get this out of the way. It's fairly simple to do because if I look at a circle, do we all agree that all the odds, this is 1 pi, 3 pi, so this is 1 pi. If I circle again, that's 3 pi, right? And do you see that this is 2 pi, 4 pi, 6 pi? So any even multiple of pi is right there, and any odd multiple is right there. If I am right here, and this is 1, 0, isn't this 1 over the cosine of 8 pi? And I know cosine is a 1. That'll make it a 1. How about negative 3 pi? Negative 3 pi. Well, the same deal. If I rotate to negative 3 pi, that's negative 1 pi, negative 2 pi, negative 3 pi, I'm right here. This point is negative 1, 0. I want the sine. Isn't the sine the y value? And this point is the same. That doesn't change. Isn't that the sine of negative 3 pi over the cosine of negative 3 pi? Wouldn't that be the sine is a 0 and the cosine is a negative 1? Wouldn't that be a 0? And how about 34? 180 degrees. I know exactly where that is. (180 degrees) is right there. Isn't that negative 1, 0? Cosine is a 0 minus, and sine is a negative 1. 0 minus a negative 1 is 1. How about this problem? It seems we have two angles to worry about. No big deal. We could deal with that. I'm going to shift this to the right a bit. There we go. And if I fit that through it, then I'll notice that (90 degrees) is right there. That's 0, 1. This is 5 times the cosine is the x, that's a 0, minus 8 times 270 degrees is right there. Isn't that 0, negative 1? The sine of that is the y, that's a negative 1. So that is 0 plus 8, which is 8. Pi is right here. Secant of pi is 1 over the cosine of pi. That is 1 over, isn't this point negative 1, 0? So isn't the cosine the x? Minus 1 over the sine of pi over 2. Pi over 2 is right there. Sine is a 1. So this is 1 over 1. So this is a negative 1 minus 1, which is a negative 2. Now, the beauty of what's to come. If I look at number 56, 390 degrees, I need to know what the coterminal angle to that is. So, this is 360 degrees and another 30. You're right there. If I subtract 360 degrees, that's the equivalent. That's exactly 30 degrees. I could use trigonometry. And I could say 30 degrees is right there. There's the cosine, there's the sine, and tangent is 1/2 over 1 radical 3. Radical 3 over 2, sine over cosine. Or I could use the triangle. I could say, wait a minute, I am familiar with this. If I draw a triangle, and I could get everything from a triangle of 30, this is 1, this is 2, this is radical 3. If I call this theta, the sine of theta is opposite over hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tan of theta is the opposite over the adjacent. The only reason I need to know which quadrant I'm in to know which of those is positive and which of those is negative, by the way, I didn't mention. Do we agree that in this quadrant x is positive and y is positive? Do you see in this quadrant x is negative and y is positive? In quadrant 3, aren't they both negative? And in quadrant 4, x is positive, y is negative. So you could really refer to it that way. If I'm in quadrant 2, the value I can get from the triangle, but I know if it's a sine, it's positive, and if it's a cosine, it's a negative. Somebody came up with a nice way of remembering that by remembering that all students take calculus. In quadrant 1, all the trig functions are positive. In quadrant 2, only the sine is positive, which means the tan and the cosine are negative. In quadrant 3, only the tangent is positive, which means the sine and the cosine are negative. And in quadrant 4, only the cosine. So this is a metaphor for you to remember. You could use x and y instead. All students take cocaine, or all students take calculus, either way. So something that we're going to need, since this angle is in quadrant 1, all of these are positive. Half of the credit will be given whether you get the value right or not, and the other half if you get the plus or minus right or not. 240 degrees. Do I know where 240 degrees is? Well, yeah, I have those circles. I could eyeball where 240 degrees is identically. I know 240 degrees is right there. All students take calc. That tells me tangent is positive. I'm going to call this theta. That tells me the sine of theta is negative. And the cosine of theta is also negative. Well, how am I going to figure out the rest? That's really simple. If you take this 240, what's the reference angle? The reference angle will give it away. The reference angle runs to the x-axis. If this is 240 and this is 180, what does that leave this with? From 180 to 240, isn't that 60 degrees? Wait a minute. I know that triangle. If this is 1, this is 2, this is radical 3, or reference angle of 60 degrees, I could come using trigonometry. There's 60 degrees. Sine is radical 3 over 2, cosine is 1/2, and tangent is sine over cosine. Or I could use geometry, which is not in this book, but we covered it. I could say sine is of 60, the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. I'm listing only 3 of those, assuming you could list the other 3 by taking the reciprocals. The beauty of radians, if you call this theta, the sine of theta, I can get the values in no time. And why is that? Because 5 pi over 6 has a reference angle of pi over 6. Sine is 1/2, cosine is radical 3 over 2. Sine is 1/2, cosine is radical 3 over 2, and tangent is sine over cosine. Or I could draw the triangle. I could say, remember, this is the reference of 30 degrees, 1, 2, radical 3. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. What's left? Where is 5 pi over 6? That's why you need those. 5 pi over 6 is right there. That's in quadrant 2. And in quadrant 2, what do I know? Only the sine is positive. That makes the cosine a negative and the tangent a negative. Pretty cool, huh? 3 more to go. Alright, and here, again, if I call this angle theta, I want the sine of theta, the cosine of theta, and the tangent of theta. I recognize that this is pi over 4, one of 2 options. Either I look at the pi over 4 right here, and I say sine is radical 2 over 2, cosine is radical 2 over 2, and tangent is sine over cosine, which is a 1. That's one way. That's half credit right there because I didn't put the plus or minus yet. Or I could say, wait a minute, 45 degrees is really pi over 4, 1 radical 2. Sine is the opposite over the hypotenuse. If you rationalize, that's what you get. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. The second question is always, where am I? And that's why you really need to look at those. 11 pi over 4. Ooh, it's too big. This is bigger than the usual. So if 11 pi over 4, you could do this if you wish. I don't recommend it, but you could say, well, that's 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. We are in this quadrant, and in this quadrant, only the sign is positive. That makes the other 2 negative. You're done. You could also say, wait a minute. This angle is too big. It's bigger than 2 pi. Subtract 2 pi from that. That's called coterminal. This will be negative 8 pi over 4. 11 pi over 4 minus 8 pi over 4 is 3 pi over 4. And by doing that, you could really eyeball where 3 pi over 4 is and figure out that in this quadrant, sine is positive. 13 pi over 6, again, the beauty of this is a reference angle of pi over 6. If I call this theta, when I say theta, I'm calling the whole angle theta, all of it. I want the sine of theta, the cosine of theta, and the tangent of theta. So, it has a reference angle of pi over 6. I know where pi over 6 is, right there. Sine is 1/2, cosine is radical 3 over 2. Sine is 1/2, cosine is radical 3 over 2. Tangent is sine over cosine. Half credit. Where is negative? That's one way. Another way is for you to say, wait a minute. That has a reference angle of 30 degrees. 1, 2, radical 3. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. You could always do that. That's why I really spent time covering section K. It's crucial for what's to come. Saves you a lot of pain. Where is negative 11 pi over 6? Well, you could say, wait a minute, negative pi, if I add 2 pi to that, that'll be 12 pi. That's negative pi over 6. If I add another 2 pi, that's 11 pi over 6. I know where 11 pi over 6 is. There's 11 pi over 6. It's in quadrant 4. And if it's in quadrant 4, I know cosine is the only positive. The other two must be negative. If you're not getting this, that's okay. We're going to do this again in section 1.3. It's not going away. And this is where geometry cannot help. Only trick could work. Where's 5 pi? We know that's 1 pi, 3 pi. We agreed that any odd multiple of pi is right there. And we know this point is negative 1, 0 on the unit circle. So if I call this theta, the sine of theta is the y, the cosine of theta is the x, and the tan of theta is the sine over cosine. Sine is 0, cosine is negative 1, and tangent is the sine over the cosine, which is a 0. And there it is. Again, I'm only listing 3 of those, assuming you could list the other 3. By the way, the cotan of theta is 1 over 0, which is undefined. And there's the homework listed right there.